Okay, so hi everybody. Here we are trying to make the best of a less than ideal situation. Um, and so this video will be me kind of walking you through taking a redox reaction and balancing it in basic solution. Hopefully you've had some time to practice in acidic solutions and you kind of you've gotten the step-by-step process kind of down pat and you're starting to move a little bit faster through it. So this is an extra little wrinkle to the situation. Thankfully, you don't have to just throw everything out that you've learned about in acidic solution. You don't have to learn a whole different way of balancing it. You just need to learn what basically is a conversion methodology. So as you can see on the screen there, I've got steps to balancing in basic solution. And what I'm going to do is I'm going to go through an example and I'll show you, and I'm going to write down the step-by-step process to it. It's also in the notes. I used a different example in the notes in N34, but the principle's the same. Okay, and I talk about it exactly the same. I'm not sure I use the exact same wording, but it'll be pretty darn close. So you can see that I've got a couple of steps already written down here, and you can see down towards the bottom there's going to be an example that I'll walk you through, and I'll go through it step by step, and as I'm doing it I'll come back and I'll be writing down the steps up above. So step number one is which is helpful, is to balance the equation in acidic solution as you normally would. So you don't have to learn a new technique of how to balance it. You plain and simply balance it in acidic solution as you would previously have done. Okay, so that's number one. Number two, once you've got it balanced in acidic solution, you are then going to convert it to basic solution. And there's kind of there's a step-by-step how to convert an acidic solution to a basic solution. And I'll walk you through all that, and then you'll kind of see how it works, and you try a few, and it's relatively straightforward. You should be able to, even the ones that in your practice sheet there was, I think, 15 questions, and of those 15 it asks you to balance them in basic solution. But once you actually learn the technique of how to convert a balanced equation in an acidic solution, and you learn how to convert it over to basic solution, you should be able to take all 15 of those and convert it to a basic solution. And to be honest with you, the acidic one, or the ones that ask you to do it in basic, you should be able to have those balanced in acidic as well. Okay, so all of these redox reactions that I'm going to show you, they can either be done in acidic or basic solution. Okay, so here we go. So step number one is to balance your redox reaction in acidic solution as you normally would. So even though it says right here, it says basic over here on the right hand side, I'm going to ignore that for a little bit. My final answer will be in a basic solution, so it's going to have hydroxides in it. But I'm going to ignore that for now. I'm going to pretend it's an acidic solution. Okay, so very first thing that I do when I'm balancing is I connect my two half cells. So I think it's probably going to be the 2 carbon compounds, and then the 2 sulfur compounds are going to be together as well. And I don't know if you've already figured this out through most of the practice, that more often than not, because of their really high priority and oxidation number, hydrogen and oxygen rarely do anything. They're not usually the things oxidizing or reducing. It's usually the other things that are in the equation. So anyways, let's separate these things. So I'll do I'll do the CH4 one first. So CH4 is going to go to CO2, and I balance oxygens by adding water molecules. So there's 2 oxygens on the right hand side. I will add 2 water molecules on the left hand side. That means I now have a grand total of 2 times 2 is 4, plus another 4. I've got 8 hydrogens, so I'll put 8 hydrogens over here. The left-hand side has a total neutral charge. The right-hand side is +8. So to make those equal, I am going to add 8 electrons over here on the right-hand side. So just to review this, that is a half-cell reaction, and it would be the oxidation half-cell reaction because it's producing electrons. And so CH4 is oxidizing to produce CO2. Okay, just generally speaking. Okay, so there's the balanced oxidation half cell. The S2O8 -2 turning into H2S is therefore going to be my reduction. But my steps, there we go. I've got 8 oxygens on the left-hand side, which means I have 8 water molecules. Oh, wait a minute. Hold the phone. I did not balance the non-oxygen non-hydrogens. So there's 2 sulfurs. I need to put a 2 in front of that first. Now I can go and I can balance the waters. So I have 8 oxygens. Therefore I need 8 water molecules over here. That is going to give me a whole slew of hydrogens. So 8 times 2 is 16. Plus 2 times 2 is 4. 16 plus 4 is 20. H pluses over on this left-hand side. That's a big number. Okay, so the right-hand side is neutral. The left-hand side is 20 times +1, so plus 20, minus 2, so that side is plus 18. To make those two charges equal to each other, so plus 18 and neutral, I need to add 18 electrons to this side over here. And there is your balanced reduction half cell. Electrons are on the reactant side, so it's a reduction. Okay, so there are the 2 half cells, and the half cells are balanced, but the electrons are not balanced. So the oxidation produces 8 while the reduction uses 18. So what number am I going to have? Well, I think the easiest way is you can multiply the other one, right? So I can multiply the top one by 18 and the bottom one by 8. But those are going to be massive numbers. And that's actually not the lowest common multiple. The lowest common multiple is not 144. The lowest common multiple is actually 72. So if I take the top one and I multiply the top one by 9, and I take, that'll give me 72 electrons, and I take the bottom one and multiply by 4, then I'll have 72 electrons on both sides, and they will cancel, and it will work out perfectly. So let's go through these numbers. So 9 times every coefficient that's in the top one. So 9 times 2 is 18, and then 9 times 8 is 72, 9 times 8 is 72, and then in the bottom, 4 times 18 is 72, 4 times 20 is 80, 4 of those guys, 8, and 32. Okay, so now what I'm going to do is, and I tend to do this from this stage. Some people like to rewrite everything before they start canceling because, let's face it, what's up here on the screen is chaotic, right? You can really easily lose track of what's going on up here. But nonetheless, I'm going to go from what this is. Okay, so what I'm going to do is I typically, to kind of reduce the chaos, I always go with, I'll use my little highlighter thing here, I always go with the things that were part of the original reaction because they're never going to cancel. I think I said that to you before. So I'm going to have on the left hand side, I'm going to have 9 CH4s. I'm going to have 4 S2O8 -2s. And on the right hand side, I'm going to have 9 CO2s and 8 H2S's, right? And so I've got those. Now I can just focus on the waters, which are there and there, and I can focus on the H pluses, which are there and there, right? Because the electrons have already canceled. So look at the waters. So 18 waters will cancel 32 waters and leave you with 14 waters on the product side. So I've got 14 H2O on the product side. With the H's, the 72 H pluses on the top there cancel those guys, leaving behind 8 H pluses. Okay, so we could run through this and we could go through all the atoms to see if they're all balanced and to see if the charge is balanced, but I think the quick way is you've got +8 and -8. That makes that side on the left hand side neutral and the right hand side is neutral. So it's likely they're going to be balanced. If you want to check one of the complicated atoms, like one that's all over the place, if they balance, it's probably okay. So I'll choose the hydrogens as an example. So I've got 8 hydrogens plus 9 times 4 is 36. So I've got 44 hydrogens over there. 8 times 2 is 16 plus 28 is 44. So the hydrogens are balanced, and it's a fairly complex number of hydrogens. And the charge balances, so that's probably correct. So I've just balanced the equation as it says in step number 1 there, balance the equation in an acidic solution. Now what I'm going to do is I'm going to take this equation and I'm going to convert it. So if you get to this stage of any balancing or redox equation, you can then convert it over to a basic solution. Now here's what you're going to do. Here's the concept is you are going to somehow eliminate the H pluses, and you're going to replace them with OH minuses. Now, one thing we do know, and this is helpful from the acid-base unit, is that H plus and OH minus, when you combine those two, they form a water molecule. So they neutralize each other, right? So what I'm going to do is once I have an acidic solution, I am going to focus my attention on the H pluses of that line. And I'm going to say to myself, how many H pluses do I have? And I will, because there's 8 H pluses on the left hand side, I'm going to, okay, think of this, it's kind of a math concept, I'm going to add 8 hydroxides to it. Now what that is effectively going to do is that is going to make the left hand side the 4s2o8 -2 and the 9 CH4s aren't going anywhere, but the 8 H pluses and the 8 OH minuses are going to make 8 water molecules because they combine to form water. So it's like the H pluses are gone. They got neutralized. Now, math concept, you're allowed to, chemistry is kind of the same here. Whatever you do to the left-hand side, you do to the right-hand side. So to keep this whole equation actually equal, if I added 8 hydroxides to the left-hand side, I'm going to add 8 hydroxides to the right-hand side. And if I go ahead and do that, over on the right-hand side, there's no H pluses for them to combine with, so they're just like straight up adding to that right-hand side. So the right-hand side, and I'll take an extra little step, I'm not really sure I would expect you to write all this down. I will go through and I will have, I'll put the hydroxides here, and 14 H2O. I guess it doesn't really matter what order you put them in. So they're not combining with anything, they're just straight up adding to the right hand side. But now, once you've done that, what will always happen is your water molecules now are going to be an interesting little scenario, because now I've made, and over on the left hand side I've got 8 water molecules, but now over here on the right hand side, those 14 that were originally there, they shouldn't be there anymore. So you can see that those 8 are going to cancel some of those, obviously not all of them, and leave behind 6 because 14 minus 8 is 6 water molecules. And so what actually ends up happening is you end up having, and I'm going to shift this a little bit so that it doesn't take up quite as much space on the right hand side. So on the left hand side you still have your original reactants, and then I've got 9 CO2, 8 H2S, 8 hydroxides, and there's hydroxide, right? So it's basic solution, and 6 water molecules. And then again, if you want to just double check, the charge on the left hand side is now minus 8, the charge on the right hand side is minus 8, and hydrogens, let's do hydrogens again. On the left hand side there are 36, and on the right hand side you have 8 times 2 is 16, another 8 there for 24, and then another 12 for 36, and the hydrogens are balanced. So it is, because the hydrogen is kind of a complicated one, and the charge balances and hydrogen balances, it is likely I've got the correct answer. So that is the reaction balanced in basic solution. And the only difference you're going to see is there's still going to be water involved, right? Water's still going to be around, but you're going to see that the hydroxides and the H pluses are, they don't necessarily switch side. More often than not they switch sides, but they don't necessarily switch sides. But the water molecule, the number of water molecules changes because of that neutralization. Okay, and so that process, when we go back to here, the first thing we're going to do is we're going to, when we're converting to basic solution, we are going to add equal OH minuses as there are H pluses in the balanced equation. Now, if I actually asked you to do a half cell reaction in basic solution, you'd just stop part way to have electrons in it, and you'd do the exact same conversion technique. You just add hydroxides and turn them into water. Add equal hydroxides as there are H plus in the balanced equations to both sides. That's number one. Number two, the H plus, I should make that plural, and this isn't officially the right plural way. The H pluses and OH minuses combine to form H2O, and then 3 cancel the H2Os and add. Okay, so that conversion technique, you get down to your H plus, so you get down to your balanced in, the double star thing here, you get down to your balanced H plus reaction in acidic solution, and then you convert it by adding hydroxide to both sides, make some water, cancel those to see what the net total is now, and then you've got your hydroxides in your final reaction. Okay, so that is balancing in basic solution. Give that a whirl with some of the practice, and like I said, any equation that's balanced in H plus, you should be able to convert it over to OH minus. Okay, see you later.